KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, we're discussing trigonometry concept, trigonometric functions. Okay. Now first exercise, before first exercise we discussed 1, 2, 3 examples. Okay, example 1, example 2 and example 3. Okay. In last class we discussed mainly about degree measure and radian measure. Okay. Now how to calculate angle we discussed, and degree measure and what is radian measure, and relationship between degree measure and radian measure. Okay. So what is important point I told you to remember? Pi is equal to 180 degrees. Pi radians is equal to 180 degrees. And one more point I told you, if a circle of radius r, an arc of length L subtends an angle theta radian at the center, then relation between L, R and theta, where L is length of the arc, R is radius of the circle and theta is angle, okay, angle theta in radians. Okay, then relation between L, R and theta is equal to L is equal to R theta. L is equal to R theta. Okay. Now example 1, example 2, example 3 already we discussed. Next example 4. A minute hand of a watch is 1.5 centimeter long. Minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? How far does its tip move in 40 minutes? Okay, here we have to use pi as 3.14. Okay, a minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? My minutes hand, in 60 minutes it will make one complete revolution, no? One complete rotation, one complete revolution. Okay, so 60 minutes is how much? 360 degrees. Okay, now a minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? So 40 minutes means 20, 20, 20 if you consider. Okay, 60 minutes if you divide in 3 parts, 20 minutes, 20 minutes and 20 minutes. So 40 minutes is nothing but 2/3 of its revolution. 2/3 of its revolution. Okay, 60 minutes is equal to 360 degrees. So 40 minutes is equal to what? 40 minutes is 2 by 3 times of 360 degrees. 2 by 3 times of 360 degrees. Okay, now 360 degrees is nothing but 2 pi. So 2 by 3 into 2 pi nothing but 4 by 3 radians. 4 by 3 radians. Okay, now here theta in radians is what? 4 pi by 3. 4 pi by 3. Theta in radians is 4 pi by 3. Okay, and minute hand of a watch is what? 1.5 centimeter long. So radius is what? 1.5 centimeter. Now how far it's move in 40 minutes? Okay, L is equal to, we have distance traveled is L is equal to R theta. L is equal to R theta. Okay, so L is equal to R is how much? 1.5 centimeters. Theta is 4 pi by 3. So here what we can write? 1.5 once, 1.5 2 cancel, 2 pi centimeter. 2 pi centimeter, pi what value we have to use? 3.14. So 2 into 3.14 is 6.28 centimeters. Okay, given that minute hand of a watch is 1.5 centimeter long, radius is 1.5 centimeter, how far does its tip move in 40 minutes? Okay, in 60 minutes, minute hand makes one complete revolution in 60 minutes. In 40 minutes means it is 2/3 of a revolution. Okay, so 60 minutes is equal to 360 degrees. So 40 minutes is equal to 2/3 of 360 degrees. We write in terms of radians, theta is equal to 4 pi upon 3 radians. Okay, so required distance travel is what? L is equal to r theta. Okay, L is equal to r theta formula. So r is how much? R is 1.5 centimeter. Theta in radians is 4 pi upon 3. Okay, 1.5 ones, 1.5 twos. 2 cancel, 2 pi. 2 pi centimeters is nothing but 2 into pi value we have to use it as 3.14. 2 into 3.14, that is 6.28 centimeters. Okay, next example 5. If the arcs of same length, arcs of same length, so L same, in two circles subtend an angle of 65 degrees and 110 degrees at the center. Find ratio of their radius. Find ratio of their radius. Here what is given? Length of arc of two circles. Okay, if the arcs of same length in two circles subtend an angle of 65 degrees and 110 degrees at the center. Okay, two circles are there, for those two circles arc length same, L is same. Okay, one theta 1 is 65 degrees, other theta 2 is 110 degrees given. Then we have to find ratio of their radii. Okay, now we'll consider r1 is radius of first circle and r2 is radius of second circle. Okay, let r1 and r2 be radii of two circles. Now first angle is what? Theta 1 is 65 degrees. To use L is equal to r theta formula, theta has to be in terms of radians. Now 65 degrees in terms of radian, pi by 180 into 65, because 180 degrees is equal to pi radians, 1 degree is equal to pi by 180 radians, 65 degrees is equal to pi by 180 into 65 radian. So nothing but if you cancel 5, 13 pi upon 36 radians. Theta 1 is 13 pi upon 36 radians. Now theta 2 is what? 110 degrees. Theta 2 is 110 degrees. Now again using same formula, 110 degrees in terms of radian is pi by 180 into 110. Okay, pi by 180 into 110. So because here 36, here 0 cancel, 11 upon 18, 11 pi upon 18, or else 22 upon 36 radian. Okay, now L be the length of each of the arc, then L is equal to r1 theta 1, also L is equal to r2 theta 2. So L is equal to what? r1 theta 1, that is equal to r2 theta 2, because length of both the arcs are same. So r1 theta 1 is equal to r2 theta 2. So what is r1? R1 we have to find. No, r1 r2 ratio we have to find. Theta 1 is what? 13 pi upon 36 r1. 13 pi upon 36 into r1 is equal to 22 pi upon 36 r2. Okay, 36 cancel, pi cancel. So r1 upon r2 is what? 22 upon 13. Okay, r1 upon r2 is 22 upon 13. So r1 is to r2 is nothing but 22 is to 13. Clear? Next, exercise 3.1. Exercise 3.1, similar question to example 5. So I will discuss question number 6 here. First of all, if two circles arcs of same length subtend angle 60 degrees and 75 degrees at the center, find the ratio of their radii. My example 5. Now exercise 3.1 sixth question, both are similar questions, only difference is angle. Okay, so here like in previous problem, here also what is given? Two circles arc of same length. So L is same, theta 1 is 60 degrees, theta 2 is 75 degrees. Okay, find the ratio of their radii. So R1, R2 be the radii of two circles. Theta 1, it is given in terms of degrees, we have to convert in terms of radian, because L is equal to R theta formula, theta is in radian. Okay. So theta 1 is equal to 60 degrees. Now 60 degrees is nothing but pi by 3 radians. These are basic things you have to know. Okay, 60 degrees is equal to pi by 3 radians, because 180 degrees is equal to pi radians. Divide both sides with 3. 60 degrees is equal to pi by 3 radians. Okay. So 75 degrees, theta to 75 degrees is equal to what? Pi by 180 into 75. Okay, 5 cancel. So what we have? 5 pi upon 12 radian. Okay. Now what is given? L be the length of each arc. So L is equal to R theta 1, also L is equal to R theta 2. So L is equal to R theta 1, that is equal to R theta 2. Now R1 into theta 1 is what? Pi upon 3. So pi upon 3 R1 is equal to theta 2 is what? Theta 2 is 5 by 12 into pi. 5 pi upon 12 into R2. Pi cancel on both sides. Okay, 3 ones, 3 fours. Okay. Now what we have? R1 upon 3 is equal to pi by 12 into R2. Okay. Now R1 is equal to 3 this side and R2 this side. R1 upon R2 is what? 3 ones, 3 fours. So 5 upon 4. So R1 is to R2 is 5 is to 4. R1 is to R2 is 5 is to 4. Okay. I'll repeat once again. What is given is two circles, each of having same arc length. Okay, in two circles, arc of same length, subtend an angle of 60 degrees and 75 degrees at the center. Find the ratio of their radii. Okay, relation between length of the arc, radius and angle at the center. Theta in terms of radians is L is equal to R theta. Okay, now two arcs length is same. So L is same in two circles. Whereas theta 1 is 60 degrees. 60 degrees is nothing but pi by 3 radians. Theta 2 is 75 degrees. 75 degrees is nothing but pi by 180 into 75. 5 cancel. 5 pi upon 12 radian. Okay. Now relation between L, R1 and theta 1 is L is equal to R1 theta 1. Okay, relation between L, R2, theta 2 is L is equal to R2 theta 2. So L is same, so R1 theta 1 is equal to R2 theta 2. Now equating these two, where theta 1 is pi by 3, so pi by 3 R1 is equal to R2 theta 2. Theta 2 is 5 pi upon 12 into R2. Pi cancel on both sides. So what we get? R1 upon 3 is equal to 5 by 12 into R2. Right? R2 this side, 3 this side. 3 cancel. R1 is to R2, or R1 upon R2 is 5 upon 4. Okay. So R1 is to R2 is what? 5 is to 4. R1 is to R2 is 5 is to 4. Okay. Next, question number 1. First question. Find radian measure corresponding to degree measure. Find radian measure corresponding degree measure. Means they will give degree measurement. We have to find corresponding radian measurement. Okay. Here basic rule is 180 degrees is equal to pi radians. 1 degree is equal to pi by 180 radians. Okay, 1 degree is equal to pi by 180 radians. So 2 degrees is equal to 2 pi by 180 radians. 3 degrees is equal to 3 pi by 180 radians. Like that we'll find. Now 25 degrees. So 25 degrees is equal to what? 25 degrees is equal to 25 into pi by 180 radians. 25 degrees is equal to 25 into pi by 180 radians, because 1 degree is equal to pi by 180 radians. 25 degrees is equal to 25 into pi by 180 radians. Okay. So 5 cancel here. 5 pi by 36 radians. So 25 degrees is equal to what? 5 pi by 36 radians. Okay. Next. Second one, minus 47 degrees 30 minutes. Minus 47 degrees 30 minutes. Okay. Now minus 47 degrees 30 minutes, I'll write like this, minus of 47 plus 30 degrees is nothing but 30 minutes is nothing but half degree, because 60 minutes makes 1 degree. 30 minutes is nothing but half a degree. So nothing but minus of 47 plus 30 upon 60 degrees. We are writing in terms of degrees everything. 30 minutes is nothing but if you write in terms of degrees, 30 by 60 minutes. So nothing but half degree. So minus of 47 plus half. Okay, 95 by 2. So minus 95 by 2 degrees. Minus 95 by 2 degrees. Now degrees to radians. Degrees to radian simply multiply with pi upon 180 radian. Okay, pi upon 180 radian. So minus 95 by 2 into pi upon 180 radian. Okay, cancel 5 in numerator and denominator. Ma. So what we get? Minus 19 pi upon 72 radians. Minus 19 pi upon 72 radians. Okay, here given degree measurement is minus 47 30 minutes. Minus 47 degrees 30 minutes. 30 minutes is nothing but half a degree because 60 minutes makes 1 degree. Okay, 30 degrees makes half a degree. So 47 plus half, 47 plus half, 47 and a half degrees. Or else if you write mixed fraction to improper fraction, 95 upon 2 degrees. Minus is there, so minus 95 upon 2 degrees. Now degrees to radian measurement, simply multiply with pi upon 180. Okay, so minus 95 upon 2 into pi upon 180, cancel 5 in numerator and denominator, will get minus 19 pi upon 72 radians. Okay, next question. Okay, in first question itself, third one, here we have to convert degrees to radian. Okay, 240 degrees. So simply whatever degrees to convert to radians, multiply with pi upon 180. Pi upon 180. So 240 degrees is equal to 240 into pi upon 180. Okay, 0 0 cancel, 0 0 cancel, 24 18. So 6 you can cancel, no? Okay, 6 3 6 4. So 4 pi by 3 radians. Okay, 240 degrees is equal to 4 pi by 3 radians. Okay, next 520 degrees. 520 degrees in terms of radians, 520 degrees is equal to 520 into pi by 180 radians. Okay, 0 0 cancel, 2 also cancel, no? So what will get? 26 pi upon 9 radians. Okay, but degrees to radian, simply multiply, standard, right, in standard form of degrees, like 25 degrees, 30 degrees, 40 degrees, something like that you write in terms of degrees. Okay, degrees to radians is simply multiply degrees multiplied by pi by 180, converts to radians. Okay, but when it is given in minutes form or second form, first you convert to proper degrees, then multiply with pi by 180. Okay, changes to radians. Okay, next, second question, find the degree measure corresponding to following radian measure. Use pi is equal to 22 upon 7. Now here they will give radians to degrees we have to convert. Okay, here one basic thing I told you to remember always, 180 degrees is equal to pi radians. So 1 radian is equal to what? 1 radian is equal to 180 by pi degrees. 1 radian is equal to 180 by pi degrees. Okay, so 2 radians is equal to 2 into 180 by pi degrees, like that. So here in second one, first question is 11 by 16 radians. 11 by 16. So nothing but 1 radian is equal to what in terms of degrees? 180 by pi degrees. So 11 by 16 radians is 11 by 16 into 180 by pi degrees. Okay, 11 by 16, 180 by pi is what? Pi we have to use 22 upon 7. So by 22 by 7, 7 comes to numerator. Okay, now here 11 ones, 11 twos, 11 ones, 11 twos. Okay, now here after simplification 4 table we can cancel, no? Okay, 4 fours and 4 45s. So 45, now 4 into 2, 8 in denominator. So 45 into 7 upon 8 degrees. Okay, now 45 into 7 upon 8. 45 into 7 is how much? 315 upon 8 degrees. Okay, now 315 upon 8 degrees, this one will convert further in degrees, minutes and seconds. Okay, now 315 upon 8, what we can write is 39 degrees plus 3 by 8th part of a minute, 3 by 8th part of a degree, 3 by 8th part of a degree. Okay, 3 by 8th part of a degree ma. Okay, now actually what we have is 39 into 8 is 312. So what we can write is actually 39 into 8 plus 3 by 8, so nothing but 39 plus 3 by 8th part of a degree. So 39 degrees plus 3 by 8th part of a degree. Now 3 by 8th part of a degree, now 1 degree is equal to what? 60 minutes. 1 degree is equal to 60 minutes. So I will convert 3 by 8th part of a degree in terms of minutes. So 39 degrees plus 3 by 8 into 60 minutes. So 8 ones. Okay, now here 4 we can cancel, no? 4 2s 4, 15, 15 3s 45. So 45 by 2 minutes. 45 by 2 minutes is nothing but 22 plus half a minute, 22 minutes plus half minute. Half minute is nothing but 1 minute is 60 seconds. So half minute is what? 30 seconds. So final answer is 39 degrees 22 minutes 30 seconds. So 11 by 16 radians, 11 by 16 radians is 39 degrees 22 minutes and 30 seconds. Okay, now here first of all 11 upon 16 radians to degrees we are converting. So 11 upon 16 into 180 by pi degrees. To convert radians to degrees, we have to multiply with 180 upon pi. Okay, so 11 by 16 radians is equal to 11 by 16 into 180 upon pi degrees. So 11 by 16 into 180 upon pi value is 22 by 7. So denominator 22 by 7. So 22 denominator, 7 in numerator. After simplification we got 315 upon 8 degrees, that we can write as 39 into 8 plus 3 upon 8, nothing but 39 plus 39 degrees plus 3 by 8th part of a degree. Okay, 3 by 8th part of a degree I'll convert in terms of minute. Okay, 1 degree is equal to 60 minutes. So 3 by 8 into 60 minutes. After simplification we have 45 upon 2 minutes. Okay, 39 degrees plus 45 upon 2 minutes. Now this is nothing but 22 divided by 22, 1 remainder is there, no? So half minute. Okay, so 39 degrees plus 39 degrees plus 22 minutes plus half a minute. Okay, half minute in terms of seconds is 30 seconds because 1 minute is 60 seconds. So half minute is 30 seconds. So 39 degrees 22 minutes 30 seconds. Okay, next question. 5 pi by 3 radians. 5 pi by 3 radians will convert in terms of degrees. Now 5 pi by 3 radians is equal to 5 pi by 3 into 180 by pi degrees. Okay, radians to degrees, simply multiply radian measure with 180 by pi degrees. So 5 pi by 3 into 180 by pi degrees. Pi cancel. Okay, 3 ones, 3 60s, 60 into 5, 300 degrees. Okay, next 7 pi by 6 radians will convert in terms of degrees. 7 pi upon 6 radian is equal to 7 pi by 6 into 180 by pi degrees. Okay, pi cancel ma. 6 ones and 6 30s, 30 into 3, 30 into 7, 210 degrees. Okay, 7 pi by 6 radians in terms of degrees is what? 7 pi by 6 into 180 by pi degrees. Pi cancel. 6 ones, 6 30s, 30 into 7, 210 degrees. Okay, 210 degrees. Next question, minus 4 radian. Now we'll convert minus 4 radian to degrees. So what we have to do? Minus 4 into 180 by pi degrees. convert radian to degree, multiply radian to 180 by pi. So we'll get in terms of degrees. So minus of 4 into 180 by pi degrees. Now pi is 22 by 7. So what we get? Minus of 4 into 180 by 22 into 7. Okay, because the denominator 7 comes in numerator. Okay, so 2's and 11's, 2 cancel here. 2 into 180 into 7 is 1260 by 11 degrees. So 2 into 1260 is 2520. Okay, 2520 upon 11 degrees. Minus is there, minus will continue throughout. Okay, minus of if you divide 2520 upon 11, what we'll get is 229 plus 1 upon 11, mixed fraction, or you can consider as this is a remainder. Okay, quotient remainder. So 229 degrees plus 1 by 11th part of a degree. Now 1 by 11th part of a degree, 1 degree is equal to 60 minutes. So 1 by 11th part of a degree is nothing but 1 by 11 into 60 minutes. So nothing but 60 by 11 minutes. Now 60 by 11, if we divide 5 minutes plus 5 by 11th part of a minute. Okay, because 60 what we can write 55 plus 5, 55 upon 11 is 5 plus 5 by 11th part of a minute. So minus 229 degrees plus 5 minutes plus 5 by 11th part of a minute. Okay, further 1 minute is equal to 60 seconds. So I'll convert this in terms of seconds. So 5 by 11th part of 5 by 11 into 60 seconds. Okay, so 5 by 11 into 60, nothing but 300 by 11. 300 by 11 approximately will get 27 point something will get. Okay, so anyhow 27 seconds. So approximately what will get? Minus 4 radians is equal to minus of 229 degrees 5 minutes 27 seconds, approximate value. Okay, approximate value. Okay, next question, question number 3. A wheel makes 360 revolutions in 1 minute time. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Okay, how many radians it may turn in 1 second? Okay, so in 1 minute how many revolutions is something like car wheel? Okay, a wheel makes 360 revolutions in 1 minute. So in 1 minute 360 revolutions. So 1 minute means in terms of seconds, 60 seconds. In 60 seconds time, number of revolutions equal to how many? 360. In 60 seconds time, it is making 360 revolutions. So in 1 second, how many revolutions it will make? Number of revolutions in 1 second is 360 by 60, nothing but 6 revolutions. Okay, so a wheel makes in 1 second 6 revolutions. So 1 revolution is equal to how much? 1 revolution, 1 complete rotation is 2 pi radians, no? Okay, so as 1 revolution is equal to 2 pi radians, in 6 revolutions total is how much? 6 into 2 pi, 12 pi radians. So through how many radians does it turn in 1 second? So in 1 second it will turn 12 pi radians. Okay, that is the answer. What is given here is a wheel makes 360 revolutions in 1 minute. Okay, so in 1 minute number of revolutions equal to 360. So 1 minute in terms of seconds is in 60 seconds it makes 360 revolutions. So in 1 second it will make 360 upon 60, nothing but 6 revolutions. So 1 revolution total length is how much? 2 pi. So in 6 revolutions total angle is what? 2 pi into 6, nothing but 12 pi radians. Okay, that is the answer. Okay, ma, we'll conclude up to here. We'll continue remaining problems in next session. Thank you.